Hey guys, it's pretty windy out here. I apologize for that. I'm going to try and shield the microphone a little bit. But today we're going to talk about advanced Azure networking. And that's kind of appropriate because I am standing in front of NASA's VAB. That's right. That's where they make the big rockets.
All right, Lex. So what I have at my home network, in that's I have actually two subnets at home. I'm a super geek. I have a dot one network and a dot two network, and one's for Wi-Fi and one's just for the LAN. I have my Ubiquity router that I have sitting at home, and I have a site-to-site tunnel created to a network that I have in Azure, and I'll just say this is the Azure side. So on the Azure side, I have a VPN gateway that I'm actually connected up to, and within Azure, I have a couple of VNets, but I'm going to start with the kind of the simpler of the first part of the discussion that we're going to talk about here. So in this VNet is a 10.0.x.x, so it's a /16 subnet, and in here I've got a couple of VMs. So I have VM1 and VM2, and this is 10.0.0.5, and I've got a 10.0.0.4. So what I can do from my machine that I'm actually connected from home on is connect through that VPN tunnel through this gateway and actually talk to stuff sitting in this network over here.
Using the 10 dot addresses?
Using the 10 dot addresses, you got it. Yep. So what I've got, let's go ahead and walk through the portal here first, and I'll show you how I have it configured in the portal, and then we'll show you in action. So this is the Azure portal, and I've got a couple of virtual networks sitting here in this. I'm actually on the virtual networks page, so showing all the virtual networks that I have in my subscription. So I'm going to go to this Taste of Premier VNet. That's the one of interest that I'm running on right now.
Okay.
And just to prove my whiteboard here, here's my 10.0.0 /16. That's my network. If I go to connected devices, I've got a couple of machines. I actually have another machine that I'll talk about in a minute. That's actually, whoops, I didn't mean to click on that. I gotta wait for it to load here. Close that out. So I have a couple devices connected, and you can see the 10.0.0.5 and the 10.0.0.4. So I've got two. These are Windows virtual machines that are running right now on this network in Azure. So also within this network, when you deploy a VPN gateway, using the Azure solution. So just to quickly show how that works, like if I go to New and I type in VPN. It'll pop up here.
Okay.
So this is the guy that I've got created, this virtual network gateway.
And you created that?
I created this already. Yep. So I'm just going to show you real quick in the wizard, some of the things you have to define. So in here, our VPN gateway can actually work for an express route connection, or it can serve as an endpoint for an IPsec tunnel.
Hey, does this mean I can set up ExpressRoute without running the 50 different PowerShell?
Well, you can set up the gateway without running 50 PowerShell commands. But then there's still some stuff you got to set up if you did that.
Okay.
And there's also VPN type. So the difference between route-based and policy-based, my connection is policy-based. So that's more, think of that as more of a peer-to-peer, so it doesn't actually have the ability to define custom routes for having, as an example, like if I had a bunch of Cisco ASA devices with many branch offices, and I wanted to have all of those connect into an Azure gateway, Azure Virtual Network gateway, And those are all different subnets, different networks at my branch offices. I have to be able to do that using a route-based VPN gateway to be able to allow branch A to talk to branch B, and for all of those routes to be advertised.
So that allows you to essentially build a routing table?
Yeah, there's some other things. It supports BGP and a number of other network capabilities, but my VPN device only supports policy-based connections. So I have a cheaper device that's not able to support some of the advanced features. So you can see the drop-down immediately changed to just basic. But this is I wanted to see if the drop-downs of SKUs. We literally last night made some significant changes for the better for VPN connectivity. So the basic VPN gateway supports up to 100 megabits of connectivity. The high performance options, or high performance option rather, will allow you to have up to 200 megabits of throughput. Many customers have much more network capacity or internet capacity than that. And we just literally last night announced the support for all the way up to 1.25 gigabits of throughput. So we have some new tiers. I don't know why it's not showing up in the drop down for me at the moment. It was earlier, but I think it's still in the midst of being rolled out globally. So you can pick a tier based on speed and performance, and then you pick a network that you want this gateway to live in. And the thing that I was showing in my network that I actually have, let me back up a little bit here. I actually have two subnets. Let me go back to my my virtual network, and it's called Taste of Premier.
Okay.
All right. So in here, I've got two subnets. I have a 2/24 subnets specifically, and you have to have a subnet. I think it has to be a minimum /28 for the gateway device to sit in. So we actually deploy some network infrastructure into that special subnet to be able to allow the VPN stuff to work. So in addition to the gateway, there's a couple different options for VPN gateways. Like there's one that's a high performance one that we run in kind of an active, so we can fail over. If one of them gets rebooted, or if there's an issue with the hardware that's running on, or whatever. So you need it's more than one IP is the bottom line. So you need a subnet for that stuff to live in. So that's why I have this gateway subnet. And if I go into the gateway subnet, you can see it shows me that all 250 addresses are available, but I don't actually have I don't have all those addresses available technically, because there's some that are actually being used actively behind the scenes by my VPN device. All right, so if I go back to my address space here. I'm sorry, connected devices. And disregard the name. I was reusing that for some customer work that I was doing. So you can see this is a basic VPN gateway, policy-based. This is the public IP address that my home router is actually connecting to. And if I go to connections, I can actually see that my home network is in fact actually connected right now, which is a good thing. So this is showing the state of affairs with my tunnel, basically. So in my case, with the policy-based network, I can only have a singular connection, so it doesn't support any other connections other than what I have connected here right now. Unfortunately, just because of limitations with my router. But if it was a more advanced or a more sophisticated router, I could connect up to, I think the basic gateway allows you to connect up to 20 or 30 branches or devices up to a single gateway.
Wow.
All right, so I've got this connectivity in place, and I'm going to switch over to, this is actually a Raspberry Pi. Actually, I've got sitting on my desk next to me.
Are you sure it's not a Raspberry Pi?
Touche. Duly nice. So this is just to show you. This is representative of the picture I just drew. So I told you that I have two subnets in my home, 192.168. One subnet is for hardwired devices. Right now, it's sitting on a. I'm sorry, it's the other way around. This is actually the wireless IP address. That the .2 is the hardwired, .1 is my Wi-Fi network. On this machine, I'm going to actually ping the machine that I have running in Azure, which is 10.0. Whoops. 10.0.0.5. Interesting. It actually.
Yeah, that's pretty funny.
So you see I'm getting about 30 to 35 millisecond ping time going back and forth.
That's a Raspberry Pi bug.
Yeah, there you go. And I could actually, from here, if I went to remote desktop, I could technically connect up directly to that virtual machine if all goes well. Looks like it's having some issues going over RDP.
Well, we know you can get there, right?
Yeah, yeah, I can get there.
To be the port that's blocked or something.
Yeah,
like that.
actually, so I looked at this earlier that we actually use a Class A 10. Subnet internally to Microsoft. So when my machine auto VPN connects, my routing table gets screwed up. So
okay.
Yeah, so that's why it doesn't work for my machine. But it does. I'm proving that I have connectivity from my home office to Azure, and I actually have a remote desktop connection. All right, so this is the 10.0.0.5 is the IP address of this machine. I'm going to ping my Raspberry Pi, which is 192.168.1.48. So I've got two-way connectivity here. The routing table is actually getting advertised from my home network into Azure and vice versa.
Yeah.
Yep. So, pretty easy and straightforward to establish connectivity that way. So, another thing that we'll try doing is, let's say you have two networks in Azure, and I briefly touched upon this earlier with peering, and I'll show you how I've got that set up here as well. So, if I go to peerings under my network, you can see I just named it cross VNet peer, and if I click on this guy, my Taste of Premier VNet is actually connected to another VNet called Cross VNet Routing Test, and I literally just created that this morning just to verify all this stuff works. And you can see that
hang on, so that's a second subnet in the cloud.
This is a separate network in the cloud. You got it. Yep.
So are these guys talking in the cloud with a virtual network, or are they?
Yep. So that's a really good question. So typically, like when you have two networks connect, as is the case with my network at home and the network I just showed you in Azure, you'd have to have an IPsec tunnel between them, or you have to have something in the middle. When you have two networks in Azure that in my case, that an individual user has permission to see, they could be in different subscriptions in Azure, but recall the limitation I stated earlier. They have to be in the same region. As long as that holds true, and you have permission to both, you can wire them up internally to Azure, and without any VPN devices, without any IPsec tunnels, without any other configuration or GUI needed. And the benefit to customers is that it's very high speed. I talked earlier about the VPN gateway having a 200 megabit limit. And, that would hold true even if you had two VPN gateways deployed in Azure and tried to make them communicate. You actually create a bottleneck in Azure or in the cloud. Whereas peering eliminates that bottleneck and just allows you to have many tens of gigabits of throughput capacity between the two of them. And so I don't think we technically advertise that, but it's very, very low latency connection.
Is that in the technical docs?
Yeah. Yeah. And you can see the other requirement is that the networks can't overlap. So I had a 10 dot network, and just to change it up, I've got a 192.168, and it's a .5 network. /24.
They have to be separate network address spaces because they're separate networks.
Yeah, exactly. Yeah, there are all kinds of stuff. And in fact, I think it would probably be blocked if you tried to wire them up and they overlapped. And if you saw earlier when I went to the address space of the network I was looking at earlier, it actually gave me a warning saying, hey, this network overlaps with another address space. Well, they're separate networks, so it's not really an issue because I know that they're separate network spaces, so it's not a problem as long as I'm not going to connect them up.
Yeah.
Yep. So in this case, this is the if I go to connected devices, so this is my 192.168 network, and I've got another virtual machine that's running in this network, and this very large scale resolution is wrecking havoc on me here. I tried to highlight and I clicked on it. So this is 192.168 5.4. So that's the IP address of my second VM. And I've also made this VM internet accessible. And right now I'm kind of glossing over that part. I'll talk about how that works in a minute. But I'm just kind of showing how you can wire stuff up for starters. So I have a remote desktop connection to that virtual machine. And this is, if I do an IP config on this guy, I can see that it is in fact 192.168 5.4. So and I can see it's running. I can tell by the DNS name. This is running in the cloud. I'm not doing any sort of smoke and mirrors stuff here. And I just have this on my desktop just for us to make sure I connect to the right one. So in here I can actually ping the other VM, and you can see that I get 1 millisecond ping time. So that very quick ping times between them. And I should be able to remote desktop. So if I type in 10.0.0.5, I'm actually going to be prompted for credentials. So I can actually remote desktop from one VNet in Azure to a VM that's running in another VNet in Azure using that VNet peering.
Okay.
I'm already connected to that VM, so I'll skip out of that. You can tell that it's working by the ping time and that it responded when I actually tried to remote desktop.
So you can VPN into one of those subnets and get to the other subnet as well.
That's not completely true. So that's a really good question. So I'm glad you asked that. When you use VNet peering, let's say my home network is network A. Let me go back to the whiteboard just for. We'll go ahead and do a new one. What's next going on here? Oh, I gotta hit the plus button. There we go. Okay. So let's say my home network is A. Let's just call this home, and this is A, and this is the 10.0.x.x, and this is the 192.168.5.x, and so I can go from here to here and from here to here. I cannot go from here to here, and this has to do with the way routes are being advertised. And I could put maybe a virtual device or a network virtual appliance, maybe with two NICs that could maybe they could sit on both. They could they could advertise some routing and create paths to be able to, to do that sort of thing. But the only way to be able to allow A to talk to C, right now I've got A with a VPN gateway, and I could also have a VPN gateway here. So that so I could have two VPN connections.
Right. So two separate routes.
Yeah, exactly. Yeah. And the other way that I could do it, if I had an express route connection, I could actually enlist, the B network and the C network both in my express route circuit and advertise them that way. So that's a little bit more sophisticated, but that's a good question. Yep. All right. So let's talk a little bit about how network connectivity works, and I'm going to just create another page here. Plus. All right, bring this guy back over. So let's just, I guess I'm making everything red, not changing my color here. It just kind of looks really aggressive. I guess I could go with a little bit more muted color here. So let's say, this is the outside world. This is, we'll just, say this is the internet. And, within, and this is within Azure. And this is a VNet in Azure, so we'll say Azure VNet, and I've got my, my 10.0.0.5, VM sitting in it. What actually, and I'm going to change colors here again. So what actually sits in between the outside world and that virtual machine is something called a network security group. And what that does is, let's say that I make a request, to the public IP address. So in my example, I'm actually connected up to the public IP address that this thing has, not the private. Like, I can't connect to that, to that private IP address publicly. So when I built that VM, I had it create a public IP address. We'll talk about how that works here in a second. But if I wanted to talk to a web server, maybe running on that box, so I've got traffic coming in over port 80.
Mm-hmm.
What the network security group does is it has rules defined on it that says, okay, port 80, you're good to go. I'll let that traffic pass through. But maybe I've got go with another color here. Maybe I've got port 53, maybe a DNS request. In this network security group, if it doesn't have a rule for that, it will not pass traffic, over to that VM. So this is how we one way that we protect, a couple ways we can actually protect customer assets in Azure by only an opt-in, and we require customers to explicitly define what traffic they want to flow in and out.
Well, I was just going to ask you that. So.
Yep.
So who configures the network security group? The end user, right? He decides
exactly. Yep.
What ports he needs open. So it's essentially a firewall.
Yep, exactly. Yeah. And it does. Yeah, and there's some natting that goes on to be able to pass traffic back and forth. But
sure.
And as we saw when I was connected to the VM, the network interface on the VM doesn't have that public IP address. It's got the private IP address. So you can create a network security group at an object level. If you recall in my earlier diagram when I showed how Azure Resource Manager has virtual machines, VNets, and so forth. So you can actually associate a network security group with a VM, or I can put one at a network level and actually have many rules that actually has routing rules at a VNet level. So this time, this method usually is a little bit more difficult, because you basically have one location where rules for any VM that you have in your VNet would actually live, as opposed to doing it on a VM by VM basis.
Okay.
So let's look at how that looks like in Azure a bit. So I'm going to go ahead and go to my virtual machine.
Just one quick point. So the NSG, that's just for stuff that you want to make publicly available on the public
That is correct.
network.
Yep.
Public internet.
Yep. So this will be the first time that we dive into the. So far we've looked at everything at the network side. So now we're going to dive into some of the VM components and how you kind of bridge the two. So this is that VM that I was connected to a little bit ago. This is the 10.0.0.5 VM specifically. So if I go to network interfaces, with the modularity of Azure Resource Manager, we now have the ability to add multiple network interfaces. So this size VM, I can have 2 network interfaces, and I think we support up to 9 with some of the larger network or larger VMs. So in this case, you can see I've got a public IP address and a private IP address assigned to this. And it's also showing me that I have this security group that is associated with this network as well. So if I go dive in here, and if I go to network security group, it gives me a link to open up yet another blade to dive into the security group. All right. So this VM, I've got a couple of ports that are open on it right now. I'm using this to do some automated deployment. This is, if you can't tell from the name, it's Windows 20 Server or 2016 Con is for containers. So I'm doing some stuff with Docker. So I've got a couple other ports that I have open, and in fact, actually, maybe from a security standpoint, maybe not the best thing to do, but they're wide open. So in here, you actually set rules with priorities. The first time it finds a match, it will allow that particular traffic to flow through. So in the case of RDP connectivity, I can actually allow traffic from anywhere, or I can tell it that I only want to allow connectivity to port 3389 from a specific IP address range or a particular IP address. So if you had something public, you could actually use this as a way to further protect it. Maybe you had a remote branch office with a pool of public IP addresses. I could further protect this this machine publicly to not allow maybe you to connect to it over RDP, but only allow me to connect to it from my home office. So right now, any is literally means any. Tag. So tag has a layer 2. For those, if you're familiar with the OSI model, layer 2 is kind of a step above the physical. Yep. And a lot of the smarter switches support VLAN tagging, where you can actually have isolated networks in the same piece of Ethernet cable.
Yeah.
Tagging's a little similar. We don't support layer 2 networking in Azure from an end customer standpoint, but we do tag a couple of different types of traffic. We have traffic coming in from the internet, or traffic. We'll talk about this in a minute. From to traffic coming in from the internet to a load balancer to your machine, or traffic that just sits on private traffic. So earlier when I went to my 192.168 machine and I connected back to my 10.0.05 machine, that traffic would be classified as virtual network traffic. So it's all contained within that Azure region. So you can create a rule that only allows RDP connectivity for virtual network traffic. Maybe traffic coming over the VPN gateway, to that machine. So it's just a way to kind of farther restrict. And there's lots of well-known services in here, or you can actually just put in, a custom service. And I'm doing a port redirection, or accepting traffic rather on that port 3389, and passing it to port 3389 on the private IP address. And I've got a couple other rules that are open to for some Windows remote management and HTTP. And you can also define outbound security rules that allows this machine to talk to another machine as well. So in this case, it's just wide open. So this is how you would farther restrict or kind of refine what traffic we actually pass to that machine. So while we're on that topic, there is something called a Network Watcher, which is a fairly new thing that's in. And I say new, we're always releasing new stuff, but this is new within the past 6-8 months. I think that this was actually released. This actually allows you, like if you wanted to do troubleshooting on a network in Azure, you can't deploy a appliance or device that has a promiscuous network listener or a tool on it that listens to all the network traffic. It used to be you had to call support to actually have us capture network traffic to try to troubleshoot something. This actually allows customers to issue.
Awesome.
Yeah. So it is pretty cool. You can also see, what the security groups look like, what traffic can actually flow. What effective rules are in place, what traffic can flow back and forth. It's got some IP flow verification. So like if you wanted to actually verify traffic, from an external IP address going to an internal IP address will flow through the rules you have defined. This is a good way to test stuff.
Yeah. Hey, can we do a real quick packet capture?
Yeah, we could. I think we should be able to do that. Let's go ahead and try doing one here. So I'm going to pick our Taste of Premier resource group. So this particular, the warning it gave me is that the Network Watcher extension is not on that machine. And I'll show you, there's a spot on a virtual machine when we talk about virtual machines.
It's the Netmon agent of Azure.
Yeah, exactly, yeah. And there's a couple ways you can deploy it, but there's a really easy way to deploy it in the portal. So I've got that deployed. So we'll just call it, test cap. And we indicate, we need to have a place to store it. So let's go into an Azure storage account. And I can add some filtering to actually look for conversations between two endpoints or specific ports. So if I just hit OK here, should be good to go. So it should be capturing traffic into that storage account.
Wow.
And it's going to create I think it's the PCAP file. I'm trying to remember the extension, but it's a common one that you can use.
It's probably a Wireshark cap.
Yeah, exactly. Yep. So you can pull that down from the storage account after you disable it, and view it no different than you can with with those tools in an on-prem world.
Yeah. So how do you get the capture?
So right now, I have it going to a storage account.
So hang on just a second.
Yep.
Has it started capturing?
It says it's loading, so it looks like it's still going. And
so when does the status change when it's capturing?
That's my understanding. So yeah, there we go. Successfully. So it just told me it was successfully added. Okay. So let's go ahead and go back to here and to see if it shows us any different status. So it still shows loading.
Okay. Yeah, and we can't hit stop yet, so it's still
it's still going. So let's see. Well, we might be able to see Classic 6002. So I'm actually going to use a tool that is called this is a free tool. It's called Azure Storage Explorer. I'm going to gloss over just how to actually connect up to a storage account, but I've already connected to it. So it looks like this is actually blob containers. This is where raw data would be stored. And it looks like it's not. I don't actually see any other containers that are created here. This is boot diagnostics data for a lab VM that I have. So it doesn't look like it started rolling in there yet, but we'll check back and see if that rolls in.
Yeah, I'd love to do that.
Okay. All right. So a lot of customers don't really know about this because this is these are some pretty cool things in here, and you can also see there's some details in here. We have limits on a subscription that this will actually show you. If I go to like East US, it'll actually show me, I can have up to 50 virtual networks, and I'm using 5 in the East US. So this will actually show you quotas. This is a good way to kind of get a summary of all of that. And the other thing that it shows is this is the network security group flow log. So a lot of times, maybe for regulatory reasons or what have you, that there's some there might be some desire for actually you can see here that I'm actually starting to the evidence that I've actually started some network capturing. So you can see details of the network security groups that are active and actually see logs of those rules as they're met and allowing traffic to flow through. So this is a good way for customer audit reasons to actually get get some of that visibility. So in this case, you actually have to go to a particular network and point it to a storage account. And just like the network capture, it's actually going to be offloading all the logs in that particular storage account. So this is some pretty powerful tools that were recently released for aid in troubleshooting. All right, so we talked about VPN connectivity. We talked about inter-Azure connectivity. And then we talked about how the outside world can talk to the VM. And that's just at its simplest form. Outside world hitting the public IP address of our VM. And if I go back to the VM just to show you one final thing on that, go back to network interfaces. And this is the NIC. And if I go to IP configurations, this is actually where you can you have some details to pick what subnet within this VNet that this machine is sitting. And if I go into the IP config, you can see that I can actually disable the public IP address if I want. Right now it's enabled because that's how I was connecting to it from my earlier. And I can make this IP address can be static. So one really important thing to note is that when you enable a public IP address on a VM, let's say you go through the portal and create a VM, that IP address is not static. So if you shut down that VM, maybe to save some money during off hours, and you fire that boy back up, you're going to get a different IP address.
Right.
Unless you actually go to that IP address and tell it that it is static, and I can't do it from this screen. I'll go to another screen and we'll look at that IP address. So there's a flip on there just like this where I can make this IP address static. So when I shut down this machine, it will always get that IP address.
And that's the public facing IP address.
This is the public IP address. Yep. I can likewise do the same thing on the private side. It's never recommended to have a VM in Azure with a static public IP address. And by that I mean where you go to the VM and actually change the NIC. That is not recommended. It would work, and it technically will work. There should no technical issue with it. But let's say you need to move that VM to another network for troubleshooting. Or download that VHD to your own Hyper-V server to figure out what's going on with some piece of software that's blowing up. If you have a hard-coded IP address, it might make that inaccessible. So the recommended approach is to leave it to dynamic on the NIC on the VM when you log into the VM, and you change it at the the IP configuration level within. On that network interface in Azure. So we kind of have two different NICs. You have the NIC on the VM when you connect to it, and then you have the NIC in Azure. So we're right now looking at the NIC in Azure. And this is where you would make it static. So what happens is that VM would boot up, it would ask, do a DHCP request, and Azure would actually dole out the specific IP address that you put in here.
Cool.
So otherwise it's by default it's static. All right, so that's how you just do one for one, talk from a external endpoint to Azure. So the final thing to discuss, let me go ahead and go to make a new screen here. No, all right, I'll drag this back over. All right, so typically customers don't have just one VM. They might have a VM1 and all the way up to maybe 10 or some number of machines that they want to load balance traffic to, and then also for availability reasons, if something happens to that that machine, you still want your service or application to be up and running. So it's more typical for customers to have multiple machines that they want to route traffic to.
Right.
And there's a couple ways you can do that. One is by putting a load balancer. I'll go ahead and would change to blue for Azure for call Azure Internet Load Balancer, and this actually has the public IP address on it. When you create one of these guys, you actually create there's a what's called a back-end pool. So there's a pool of addresses this load balancer knows about, which is basically the private IP addresses of all those VMs. So this is like a layer 4 type, routing of traffic. And you can configure how this guy works if it's round robin, or any more. You can actually do 3-tuple, maybe source IP, destination IP, ports. There are a couple different ways that you can actually route traffic to machines that are over here. And the Azure load balancer is aware if this machine goes offline, it's going to stop routing traffic to it. So this is kind of more of an intelligent load balancer that's aware of stuff in Azure. Another option you have is I'll just call it a network virtual appliance. So this could be a Barracuda Windows or a web application firewall. This could be an F5 load balancer. And it works the same way. Basically, most of the vendors' network virtual appliances are Linux VMs. They have multiple NICs in them, and one of them would have the public IP, just like our load balancer, and it basically does the same sort of thing. At that layer 4 type level, layer 4 or layer 7. So we also have a third way that's called a application gateway. So this is more aware of protocols. This is a layer 7, so higher in that OSI stack. And this too has a public IP. And this actually, because this is aware of web traffic, you can do things with this saying, slash images goes to this server, and maybe slash scripts goes to this server. So you can actually set up very specialized routing rules because at a layer 7 a level, this is aware of the HTTP headers coming through and what it's actually making a request to.
The application layer.
Yeah, exactly. Yep. So this is an appliance that we actually have that you can literally go and hit I want a new application gateway. It's a highly available, virtual device for all intents and purposes. You just can't connect to it. And this has some. You can't connect to it in terms of remote desktoping or SSHing or whatever. So it's a packaged solution that we have in Azure, and we have the ability for you to also enable something called the Web Application Firewall, where this does some basic checks for SQL injection attacks or cross-site scripting attacks. So it actually can, because it's aware of that HTTP traffic going through it, it can do a little bit more application level inspection to try to protect the machines that are sitting behind here. So if you can read my chicken scratches, that's a couple different ways that you can kind of load balance traffic. And another thing that you can do that in Azure is you can actually have an internal load balancer. So we'll just call it internal load balancer. Really bad chicken scratches here. And it is exactly the same as this guy. But the difference is that it actually has maybe 10.0.0.6. It has an internal IP and no external IP. And it does exactly the same thing that this guy does, where it routes traffic to other VMs. So this is, if a customer had a line of business application that they didn't want internet accessible at all, they can actually deploy one of these in Azure as well. So without having to use one of these.
Just load balances between virtual machines.
Yeah, exactly. Yep.
So I've got a machine that's maybe a client machine. It hits the internet load balancer that's set up virtually, and that virtual load balancer figures out where the back-end servers are and routes traffic to the server that can best handle the request.
Yep, you got it. That's basically it. Yep.
Cool.
All right. So those are the ways that you can allow connectivity, kind of more complicated connectivity in, or more complicated scenarios rather. So one of the final thing that you asked about is creating a virtual network, and we'll go ahead and just do that as a final step here.
Yeah, but don't forget we've got a trace running.
Oh yeah. We'll check back to that. Hopefully we'll give it some time. I don't know how long that'll take. Let me do a refresh here, and I'll see if I got anything showing up. In my. I still don't see anything in there yet. So we'll have to see how long that takes. We'll go back to that.
Okay.
All right. So I'm going to create a new virtual network, and we will call it LexNet. And is actually, so let's see, I'm going to put it in a resource group that I'm actually, so a resource group is kind of a way to group a bunch of components together in Azure. So I'm going to put it in our Taste of Premier resource group. So this is the IP range, and I'm just going to leave it at the default, so 10.3.0.0/24, so I get 256 IP addresses. And it's going to ask me to define a subnet by default. So again, if I wanted to connect this network to a VPN or use a VPN gateway in it, I would have to be aware of that when I created it to make sure I leave enough IP or ranges or large enough subnet for the VPN gateway to sit in. In this case, it's they're both /24.
Yeah.
And literally hitting create.
So technically, the VPN gateway has to have one interface that's on your local network,
right,
in your subnet, and then one interface that's not.
Right. Yeah, and it's hidden away. I mean, if you saw when I went to my gateway subnet, I couldn't actually see the connected devices. But it just, if you actually try to create a VPN gateway, and if I pointed a VPN gateway to this network I just created, it would actually yell at me. It would say, "Hey, you need a dedicated subnet just for the VPN gateway." So, but I just created a pretty simple subnet, and if I actually wanted to, let's just show you how easy it is to actually use that subnet. I'm just going to create a Windows Server machine, and I got a couple basic bits of information I've got to provide it. We'll just call it test server, just for sake of simplicity. Put in a username and valid password. So I have to get down to the next step, which is where we really want to go. All right, so tell it to go into the Taste of Premier. All right, that bottom part save up to 40% of what, if you're a customer with software assurance, you can actually move those licenses to Azure. So it's a way to actually save a pretty significant amount of money. Instead of renting the Windows license from us by the minute, you can just use that license in Azure. So basically we will charge those customers at the Linux rate. That's what that checkbox is for. All right. So this is where all the good stuff is. So this is where I actually tell it what network I want this machine to live in, and you can see I should see my LexNet network, and it's going to that default subnet that I created in there, and it's going to create a security group, a new security group that's going to allow RDP traffic into this machine. So this is that's how this is at a simplest form how you would make use of a network that you create in Azure.
Okay.
Yep. All right. So cool stuff. Any other questions?
Dude, that's awesome. Go stop the trace.
Let's go see what that guy's doing. All right, so we got Netmon installed, and I'm going to go ahead and open up the capture file that we downloaded from Azure Storage.
Yeah.
And give it a minute here to think.
And it's loading parsers.
Yep, actually there we go. Loaded to my other screen.
Oh, there you go.
All right.
Yeah.
Yep. So there we go. So these are the conversations you can see, between, that particular machine. Remember, this is at the 10.0.0.5. It looks like it's reaching out to some public IP addresses. Some of these are probably some internal communication with the Azure Fabric, but you can do some pretty deep troubleshooting of all the conversations that occur between.
This is critical. This is so awesome that we can actually trace in Azure.
Yeah, it looks like
can't do it with Office 365 yet, I'm assuming.
No, because that's a public service, and all customers run in a shared infrastructure. This is the customer's infrastructure. So
there would be no way to figure out.
Yep. Yep, absolutely. So this is that was a pretty cool exercise. I have to admit I've not ever done that before. So that's
So do this. Let me show you something even cooler. Go up to Parser Profiles.
Mm-hmm.
Come down and select Network Monitor Profiles, and do Windows, because right now you've just got the default parser set. Do you see all the requires full common parser stuff?
Yep.
All that's about to go away. So in just a second, because we have the new parsers installed, the full parsers installed, we'll be able to read all that traffic. There you go.
Yeah, there we go. Nice. Okay.
So now do this. Type in TCP.port.
And the filter?
Yep. Exclamation point equals.
Not equal, okay.
3389.
So that would be all the
and we're pulling out all the RDP traffic.
Yep. Cool.
There you go. There's everything
the TLS
that wasn't generated by your RDP connection.
Very cool.
Now you can actually look at traffic generated by specific apps or between specific IP addresses. And if you open up a specific IP address under network conversations, you've got IP address pairs there. Just click on one of them, open one of them up.
It's interesting. So I'm wondering if, how we enabled the capture on there. I see a bunch of conversations going to Blob, Store, Core, Windows. And this is a storage account that I didn't create. So I'm wondering if that was a temporary, if the agent running on that machine is actually streaming or communicating rather with Azure Storage to actually put the parser data there.
It could be. That's port 443.
Which Azure Storage would communicate on.
So that could be what's going on.
Interesting.
Huh. Okay, so now see the IP address that you expanded out? You've got like a little UDP session riding on top of that IP address pair, and then that's actually SNTP riding on top of that UDP session.
Okay. Yeah, very cool.
Yep. Awesome stuff.
All right. Yeah, so there we go. There you have it, folks. End to end, and this time you taught me something, Lex.
Yeah, well, I've been doing the networking thing for about 20 years, so And I love it, man. That's my favorite thing to do. You see how big the smile on my face is, right? And it's because I just figured out that we could run network traces in Azure.
So now you have a reason to go do some experimentation. So you can set up a lab in there.
So I'm going to do that, and I'm going to call you and get you to help me do it. And
sounds good.
I'm very excited about it. This is just awesome. And man, thank you so much for joining us today and showing us this.
No problem.
I know that when we started this episode today, just for the folks out in podcast land, we thought this would be 20 minutes worth of stuff. And I think we ended up at about an hour and 50 minutes. So
yeah,
this might be broken up into a couple episodes. But man, I can't thank you enough. This was awesome.
Yeah, no worries. Yep, and thanks again for having me on, and looking forward to the next one.
Yeah, absolutely. So, folks, that's really all we've got today. So I'm going to say those magic words. That's your taste of Premiere.